Today we'll be talking about inflammation. Welcome to Cooking with MedSci 351. Stay tuned.
Hey everyone! Welcome to another episode of Cooking with MedSci 351. Today we're going to be exploring the wonderful world of inflammation.
Hey, have you ever hit your hand with a hammer and then experienced pain, redness, swelling, heat, and loss of function? Well, you've just experienced inflammation. And today we're going to walk you through exactly what happens in our kitchen.
So we have Michelle and Horace picking up ingredients for us, so let's check out what they're doing at the supermarket.
Alright, before we start cooking, you have to get some ingredients, right? Okay, let's head on over.
Let's go. Now that we're here, let's pick up some inflammatory mediators, endothelial cells, and leukocytes. Let's head on in. First, we need inflammatory mediators. You can probably pick these up from the inflammatory cell aisle from any of your local human grocery stores.
Some of the brand names that release inflammatory mediators are your mastocytes, dendritic cells, macrophages, and eosinophils. You know, just some cells that are present in your body. And let's go check them out right now. Alright, so there are a couple kinds of inflammatory mediators that we have here. We have your histamines, prostaglandins, chemokines, and cytokines. But for us, they kind of all work the same way. Okay, so what happens now is that these cells present your PRRs, which recognize PMPs, your cell recognition molecules, on your damaged cells or your pathogens, right? So what happens when you receive a stimulus like a burn or a cut? So what happens now is that your PRRs recognize these PMPs on the surface, and then when they bind, right, they're going to release all these chemokines, which are these guys right here, and to propagate or to kickstart your immune response. Alright, so now let's pick up some cytokines, some histamines, some chemokines, and I think that's all we need.
Right, so now that we have inflammatory mediators, we need something that they can work on. A perfect thing that everyone has in their bodies are endothelial cells. So let's go pick some up. Endothelial cells along blood vessel walls will absorb the inflammatory mediators we just picked up. That will cause them to display a lot of selectins and PAFs, which promises to be a treat your body will really enjoy. Let's pick some up right now. Okay. Almost done. Now that we have endothelial cells and inflammatory mediators, we need one more thing to finish this off with. So let's head over to produce and find that.
So the last thing on our list are some leukocytes, right? So now what makes a good leukocyte? Well, I got a really good bunch here, and what makes this a good leukocyte, right? So basically this leukocyte has interacted really well with your PAFs, right? And then your PAFs are going to bind to your leukocyte right here, and your leukocyte is going to present these integrins. And these integrins are going to react to your endothelial cells, causing to stick to the endothelial cells, stick really well, and eventually they're going to squeeze right past them into the site of injury, into where all your pathogens are, right? And I think that's the last thing we need, so let's head back to the kitchen.
Who is it? Okay. Hey guys.
Hey!
Oh, you got this stuff?
Yeah.
Nice, nice. Alright, they got it. Let's go get cooking. Hey.
Hey Amir!
Hey, they got the ingredients.
Oh, awesome! So I guess we can start cooking up our perfect inflammatory response now.
Yep, but wait, before we do that, we gotta first understand that it's a part of our innate immune system. Meaning that it's a biological response to harmful stimuli like pathogens and damaged cells. So, while it's really delicious to have a little bit, at just the right amount of inflammation, if you get too much of that stuff, remember, you're gonna end up hurting your body. Alright, so let's get cooking.
Awesome! Okay, so first you gotta take your inflammatory mediators that you got from the inflammatory cells. Michelle and Horace, they happen to pick up histamines, but there's a ton of other different ones out there, like cytokines for example. So let's take some of these and rub them really well onto the endothelial cells we got, which Amir would demonstrate for us here.
Yeah, so beforehand, I put all of them in certain bowls, and now I'm just gonna go ahead and rub it all over the endothelial cells.
Yep, you gotta make sure that you rub them really well onto the endothelial cells so they absorb completely.
Absolutely. Okay. So now, why do we want to add these mediators to our endothelial cells? Well, it's because of two reasons. First off, you increase permeability within the site of injury. And there's also contraction of the endothelial cells and vasodilation. Now, this happens because when you add the mediators to our endothelial cells, you go from an endothelial cell being about this big to this big, and that's caused by shrinkage. Now what this shrinkage does is increase the gaps between the cells. Now another thing that happens is that the basement membranes where these endothelial cells are starts rearranging. And when that happens, you get increased blood flow to your site of injury, so there's more plasma cells and there are more leukocytes that are coming to your site of injury. The second thing that happens after adding mediators to your endothelial cells is upregulation and displaying of P-selectins, along with displaying a series of molecules known as platelet aggregation factors, PAFs in short.
So once you've really rubbed the inflammatory mediators onto the endothelial cells, like Amir's been doing for the past little while, you gotta take a second and let it do its thing. So I'm just gonna set this to the side. And this is really important because once the endothelial cells have started to display P-selectins, they will bind to the receptor PSGL1 on our leukocytes, which allow our leukocytes to stick and to roll along the endothelial cells. And Amir will be prepping those for us. Okay, great. So I guess it's been sitting for a while now, and we can get started and start adding our leukocytes to make the whole thing start happening.
Okay, so the leukocytes have a bunch of receptors called PAF receptors. You guys remember the PAFs that just popped out of our endothelial cells when we added the mediators in? Well, the receptors on the leukocytes go and bind the endothelial cell PAFs that had just popped up. Now, it's really important that you don't miss the step because the binding of the PAFs to the PAF-Rs causes LFA1 integrins to display themselves on the leukocytes. And when that happens, the leukocytes LFA1 can really start binding firmly to the P-selectins, known as the ICAM1s, on the endothelial cells that also popped out alongside the PAFs.
Okay, we're almost there. Now that our leukocytes are bound to our endothelial cells, we can start getting some magic happening. The leukocytes start changing shape and flattening to squeeze between the endothelial cells and into the tissue beyond, migrating towards chemotactic agents. A fancy word for this is extravasation.
What that is?
Diapedesis.
I get it.
Okay, now that we're done, we're on to our last step. We gotta pop this onto the grill.
I'm gonna do that.
Bye.
We gotta understand that immunity, maybe after hitting your hand with a hammer, by accident of course. What the kind of sense contraction of... Now, when that happens, getting the basement membrane, after getting, a big fat, and start cutting your ECM, so then you're, what? You son of a... Didn't you say I'm